All right, the next thing we're going to do is we're going to start looking at the envelope of the building. So I'm going to click on the envelope tab, and we've got a couple different categories. We've got ceilings and skylights, walls, windows, and doors, and then we've got our foundation structure. So just to briefly talk about what that means, and I typed in thermal envelope into Google and just brought up a couple images. When we talk about the thermal envelope is the part of the building that separates conditioned interior space from unconditioned exterior space. So this is a pretty simple graphic here. House very much like the Judson, other than the ground level it's on grade. You can see that it's got insulated walls and exterior that separate it entirely from the outside of the building. So what we're going to do in the next piece of our Judson work is we are going to add in that envelope. So there are a couple things. We're going to be taking advantage of the ResCheck guide that we've started. I also am including the detailed numbers and the layout that I've done for the Judson already. So you have that, and what we're doing is going to put this in all the same. So everyone will start off with the exact same thing, and then the goal at the end of the class is to make some changes in here that improve the Judson. You'll be selecting different materials and updating some things, and hopefully it'll all make sense when we get through. So the first thing we're going to do is we're going to go ahead and click into our ceilings and skylights, and we are going to add. And we need to add a ceiling. So we're going to assume right now that we don't have an insulated ceiling, but we're going to look at a traditional flat ceiling. We're not using any of these other materials, steel joists or rafters or raised energy trusses. We're going to have a traditional flat ceiling in this case, and we're going to call it that component ceiling. We'll leave it that. And then for gross area, the gross area of our ceiling is going to be basically the same as our floor. So if we look at the first floor area, we're going to have the ceiling that's going to cover the same area as the floor. So it's going to be 1,090 square feet. So we'll go back in, and for gross area, we're going to put 1090. Now, cavity R value. You're going to see the term R value show up from here on out a lot in the class. R value is simply a material's ability to resist the transmission of energy. In this case, we're talking specifically about thermal energy. So higher R values are better. That means we've got some good R values. We're going to assume that when this house was built, we didn't use any cavity insulation. So we're going to assume that it was an uninsulated building. Now, continuous R value. When we build a building, we can also make sure that we have a continuous barrier that goes around the building. So instead of just filling a stud or ceiling cavity with insulation, we can also wrap that material with a rigid insulation. One of the things that we forget about is that the studs and the structure of the material that we build the building with actually transmit energy. So if you have an R11 insulation in your walls, your studs may only be an R5. So you don't have a true wall R value of R11. So for right now in this building, we're going to consider that everything is uninsulated. And as you read through the green from the ground up text, you will see, you'll understand a lot more about the understanding of R value. So we're going to apply that, and we have now got our flat ceiling all set and ready to go. And I'm going to save it there, and we'll move on to the walls next.